I'm going to start this meeting. It may be a minute early, but I'm still here. Welcome. I'm so glad to see faces in person here at ElderQuest, because usually I'm here by video or whatever you call it, Zoom. I'm here by Zoom from Payson. Anyway, welcome. I would like to remind you that we have a luncheon coming up in November. It is November 9th and it will be at 1 o'clock. It's the scholarship luncheon where we get to meet our scholarship recipients. They will speak and we'll tell you a little bit about how you can help contribute to the program. ElderQuest has been doing it for years and we love our students that we've been able to scholarship. I've been asked to introduce a special friend of mine. I'm going to tell you a little bit about him. His name is Bregg. He's a retired Navy nuclear submarine officer. That's a mouthful. He recently moved here from the Detroit, Michigan area to Utah Valley to be closer to his family. Lieutenant Commander Bregg, United States Navy, retired, has a broad technical and executive oversight expertise in management experience in nuclear power generation. And that career has spanned 50 years, a little bit over 50 years. He retired from the U.S. nuclear Navy field. Oh, that's a mouthful. After 20 years and then spent 30 years in the commercial nuclear electric generating industry, both in the United States and abroad. For this presentation, he was asked to describe life on a nuclear sub, as well as his experiences with the nuclear generation plants. I met Jerry. This is just a little personal aside. I met Jerry in June of this year. We met online. I'm Twitter-pated. We have marriage plans in December, so just so you know. Anyway, here's Jerry.
Good afternoon, everybody. Terry Ann's a wonderful lady, and I'm excited at our future here together. And I recognize it's we're in the twilight of our years, but nonetheless, we're still very active, and we plan to do a lot. And we love our families, and we're ready to move forward. I'm going to be covering what it was like on a nuclear submarine, particularly as a nuclear plant operator. When I was assigned to the submarine, I was a listed man, but it takes about 2 years of intensive training before I first set step on a nuclear powered submarine. It was a pretty arduous journey through all the training, and you attend schools 5 days a week, 8 hours a day, and that's not counting your after-hour study. So it was pretty intense. And that at my 8-year point, I applied to be a warrant officer, and I got accepted, and I went up through W1, W2, W3, W4, and then I went over to Lieutenant JG, over to Lieutenant and Lieutenant Commander when I finally retired. So it's rather steps. And yeah. What service were you from, sir? I see your bars on your collar. Yeah. Oh, those are suspenders. Okay, my vision is not that clear. Well, anyway, when I got at my 8-year point, I was invited to have an interview with Admiral Rickover. If anybody remembers Admiral Rickover, he's the father of our nuclear Navy. And in that interview, I'm sure it didn't last more than 20 seconds. And when I answered his question with 3 different answers, he told me to get out of his office with some very colorful metaphors and never wanted to see me again. but I ended up with a plum job working as a technical field representative for Fred, Admiral Rickover. I can tell you stories about that. Because anytime he visited a ship, or visited anywhere, it was incumbent upon the commanding officer, he better have some seedless green grapes available for the Admiral. He loves those grapes. So, and it's been known that if a commanding officer didn't have the grapes, he immediately sent somebody to get some. So it happened. Anyway, to begin, life on a nuclear submarine or even a nuclear ship is pretty arduous. And to help give you some perspective, I have a video that more aptly describes messed up. I messed up.
There it is. It's up.
It's up.
Oh, you lost it.
I lost it. Okay. There we go. And it will aptly describe life on a submarine. And you can get a visual picture of what I'm talking about there. That is a
Hello,
fleet ballistic
everyone,
missile
and
submarine.
welcome to the Fluxus channel. On today's feature, we will submerge deep under the sea surface to learn about the lives of the U.S. Navy submariners. A world shared by about 5,000 officers and 55,000 sailors in the U.S. Navy. They work in a different time frame and environment than the rest of the world. Their office and living space are in any of the 68 nuclear-powered submarines, about 200 to 800 feet from the sea surface.
In December 2008, legendary investor Whitney Tilson explained to 60 Minutes anchor Scott Pelley
Although the submarines are far more superior and advanced than when it was first introduced in the 18th century, it still cannot avoid the element of danger within its operation.
Auxiliary cast off.
It takes a certain special individual and perks to accept a job where you'll be working and living in a cramped, windowless space with no sun for months on end. And what makes it more impressive is that there are volunteers within the Navy that have been tested and proven to handle the stress of the submarine life. Once submerged, a submarine can remain underwater for about 3 months, and about 140 officers and sailors share the cramped cylindrical vessel. The submariners are not only academically and technically qualified, but they are physically well-trained and tested to survive the intense pressure differential between the surface and their undersea operating level. To ensure the physical and mental wellness of the crew, submarines have shorter deployment times compared to surface vessels. The ballistic missile submarine goes for 3 months of patrol, whereas the fast attack or guided missile submarine goes for 6 months of deployment at a time. This gives the crew a much-needed break from working in the nuclear-powered vessel filled with loaded explosives. The little available space on board is designed to be multi-purpose. The officer's wardroom becomes an operation theater in medical emergencies. The torpedo room can serve as a bunk room. The crews have to navigate through the precious and scarce space on board. About 1/3 of the vessel is already taken by the nuclear reactor and propulsion. The remaining area is shared between armaments, working, and living quarters of the submarine.
This is the world's first reusable cotton swab. It removes up to 5 times.
Every inch of the vessel is utilized, and anything taken in is meticulously calculated. The submarines are typically loaded at the point of embarkation, but so often, the submarines would resurface to be resupplied at sea. There is no space in the submarines for waste materials, so any unnecessary packaging or card boxes are removed. The crew is often supplied with enough food to last them for 90 days. There is very little space to live any sense of normalcy on board the submarine. The crew has to share the bunks they affectionately refer to as the coffins. Everything has its home, and the submarine is not a place for the messy.
I paused it, sorry.
Even shower or bathroom period is calculated in consideration to the other fellow crew on board. When the big surface vessels are equipped with barbers and shops, the submarines would only have 1 washer-dryer on board to be shared between 140 crew and officers. As there's no way to tell when breakfast or dinner is to be served, the meals are rotated every few days to cater to those working in odd shift hours. But it is the true character of the voluntary Navy crew on board that makes living in the submarine peaceful.
Those are missile tubes.
Strong camaraderie and empathy make them understand the difficulty of others. Like a simple gesture, maintaining quietness to ensure the crew's sleeping remains undisturbed. It is considered the worst rule to break, as each of them understands what a luxury sleep is to those working in staggered shifts. The submarine life is in no way a life of comfort. It is, in fact, dangerous and hazardous. Not only working with loaded explosives or the risk of being trapped in a sunken submarine, but it has a day-to-day physical and physiological effect on its crew member. The lack of sun exposure itself deprives the crew of natural vitamin D, as well as the endorphins it helps to produce.
650.
The lack of sun, in combination with the long shift hours, affect the natural internal clock of the crew. This causes sleep deprivation, which will affect their concentration while on duty. Their daily undertaking involves maneuvering between the torrent of pipes, engines, valves, and explosives. The perpetual cramped living condition and the lack of personal space over a long period of time will eventually affect the crew's psyche.
We get a little grumpy at the end.
The glimpse of sun rays may bring a brief moment of joy to the crew, but this, however, may not be enough to allow them to communicate with their dear ones. They simply have very limited contact with home. While they may be able to send emails or make a call when they're in port, the same is simply unachievable when you're in and under the sea. And even if they can communicate, they won't be able to divulge too many details, as it may affect the mission they're in. The physical and mental pressure of the submarine life is not for the faint-hearted. To the submariner, their daily life and work bring with it a certain degree of risk and danger. Their responsibility requires their dedication and undivided concentration. Despite the unforgiving condition, the submariners still undertake the challenge with professionalism and pride. That's the end of this video. I hope you enjoyed it. Make sure to subscribe to this channel so you don't miss any of our new content. See you next.
Okay, that gave you a pretty good look at what's inside a submarine. It is cramped. Every available space that you got to allow for people to be able to walk through it. And so there was adequate space for that, and where you eat and things like that. Our bunks were only, we called them coffins or racks, and they're about that deep. There isn't much space to roll around in if you're a big person. This is the submarine I served on, the USS von Steuben. It was named after General von Steuben, who served with General Washington during the Revolutionary War. He came over from the Prussian army and served with George Washington in training the revolutionary troops. And he was very effective in that. And I'm not going to go into a whole history of that, but that's what the submarine was named after. Part of the presentation needed to give you a view of the submarine. Let me see if the laser pointer I can get here. Pointer options, laser pointer. There we go. Okay, every part of the submarine is going to be divided by a wall. We call them bulkheads, and they're designed for test depth or crush depth of the crush depth of the submarine. And they have watertight hatches that we shut in terms of emergency, and they're big round hatches. And people fly through them very fast when they go to battle stations and all that. And it's not unknown, but most all sailors have probably cracked their head on the top of the hatch. It hurts, hitting solid metal. Anyway, this is a torpedo room, and there's some bunks in here. We carried a number of torpedoes, but we also carried two nuclear torpedoes. They were Mark 45s, and what would we use a nuclear torpedo for? It's usually in the warfare for an enemy who has a deep diving submarine, and we could send it down and take out that submarine to submarine warfare. And after going aft from forward part of the submarine is we come up against the cruise berthing, which is right here. Then you got provisions for stores, and then you start getting into this section of the ship, of the submarine, with the emergency battery and the missile control center. But let me just spend a little bit of time here. This is where the mess halls are and the officers berthing, and the radio rooms and things like that. So it's all support activity. And we're about, at any one time, about 1/3 of the crew is up and the rest are either watching a movie, eating, or going to sleep. So most of them are asleep because typically on a submarine, you stand 8 hours of watch at your watch station. It could be, like, for example, where I serve in the engineering spaces, the upper level engine room. You serve, you stand watch there 8 hours, taking care of the equipment, watching how it performs, and doing other necessary activities to keep the plant running efficiently. And then you get 16 hours off, but that 16 hours, and sometimes most often, is not your free time. You usually have anywhere from 4 to 8 hours of preventive maintenance or 8 hours of repair work or repair parts that need to be installed. You get some steam leaks on valves in a steam plant. They're packed with typically well, used to be asbestos with graphite, and they replaced the asbestos, but with graphite rings in the throat of the valve, and you tighten down on it, and that prevents steam from leaking out. It's not radioactive steam, which I'll talk a little bit later, but you don't want to lose the precious water you have on the submarine that we make. And I'll talk a little bit about that. So we eat well, but it really wears you out. When she said it's not for the faint heart, the narrator of the video, she's absolutely correct. Over in here is what we call the bridge. It's where the officer of the deck is directing the course of the ship by following the night orders of the captain or the XO, executive officer, is directing the course of the ship. They may relieve the officer of the deck of that responsibility and take it. Particularly in more dicey situations, you'll find them taking charge of the direction of the ship and how to fight the ship, how to fight the submarine against the enemy. And that is key. Up there, you'll find a sonar, the dive stations, which you saw the steering wheels. Those are the dive stations and the engine order telegraph. They don't control. The speed of the boat is not controlled from that position. We use it, and it's been there for ages through ships, an engine order telegraph. And they'll say a head full, and we'll get back. And that takes place back in the engineering spaces, which are here in this section of ship. And there'll be a throttleman there to control the ramp up the speed of the engine, the main turbines, to increase the speed of the ship. So it's not done up there in this part of the ship, it's done way back there. So anyway, up here, besides the sonar and weapons and the weapons control consoles and navigation, that's where the command and control of the submarine takes place. Below it, here is just the mess decks and the officers' wardroom and mess where they eat. And below here, right in this spot, is the Missile Control Center. And this is like a crew's library or kind of a resting place. But the movies are shown on the mess deck or in the wardroom. So, and then this is another wall or bulkhead with a hatch that goes into it. We had 16 missile tubes. Those missile tubes, we carried the Trident, a Trident version. We were modified to carry a Trident version of the missile. Each missile had 14 individual warheads. We call them multiple individual MIRV vehicles, okay? And they can be individually targeted. And that means we had 224 warheads there, okay? That's a pretty potent weapon. When we launched one of those, I was back in the engine room, we didn't launch a missile. We launched a water slug, or what they call a cybolt. And when they launched it to test and how you launch it is a small rocket motor for each one of those missile tubes that generates the gas to push the missile out of the tube. And what's really interesting on that, the missile, when it's launched, is not touched by seawater at all. And so it goes up through this cloud of gas, and then when it finally hits Bregg's surface, that's when the engine's ignite. Now, you wonder when they open the hatch, you know, what prevents the seawater coming in? And I'll show you that a little bit later. And then here is an auxiliary machinery space. In that space is things like an oxygen generator. If we start getting into the things to operate and to maintain our atmosphere in the ship, and there's all kinds of equipment there, like a metal lathe, a lathe to machine metals, if we need a repair activity like that, and a lot of spare parts are stored in this space for the submarine. And then up through here, there's a hatch. It's a tunnel over the reactor compartment, and this is the reactor compartment. And in that reactor compartment, it's heavily shielded. So when you talk about, I'll talk a little bit about the radiation exposure a little bit later on, but it's heavily shielded, where the radiation exposure from the reactor is it's less than what we receive out here as a normal civilian. And so we use polyethylene, borated polyethylene. And see, the reason why boron is has a high thermonuclear cross-section for the absorption of thermal energies, because these reactors are pressurized thermoreactors, and we use the thermal neutrons. And I'm not going to go into all the physics of it, but it gets rather complicated how that all works. But it's usually a fission process. Back here is AMR2, Auxiliary Machinery Space 2. Up on this deck is all the electrical distribution breakers, and also all the reactive protection gear is up here. And with all the safeguards we have to protect that reactor. We're not protecting the reactor. It is absolutely, how's the word I want to say? We must, at all costs, protect the reactor core. We do not want damage to the fuel and release of fission products to the environment. So there's 4 barriers involved. One is the fuel has cladding that, and it's pretty robust for the transfer of the heat from the fission process to water. And then we got the reactor vessel system. Then we got the reactor compartment. Then they got the hull of the boat. There's 4 barriers to prevent the release of fission products. Now, in 1968, we lost the Thresher, a nuclear submarine, and it happened because they had a flooding event occur where seawater was introduced into the ship, and it took it down. And it took it down. It was crushed. And we were not able to retrieve it at the time. It was in 8,000 feet of water, but we knew what happened. And so what born out of that is the term subsafe. And what that means, that all the material subject to seawater pressure is certified. Certifications are provided that it met all the chemistry and all the metallurgical requirements for that design of a system to sustain crush depth. And so that was a big improvement, and that's a very serious program that we need to comply with. One of my duties was on a submarine tender. I was the production officer, and I had a crew, 12 divisions reporting to me, and about 550 maintenance trades, different foundries, periscope shops, carpenters, mechanics, you name it, I had it. What made it interesting is that on a submarine, if we don't maintain the system subsafe, they cannot dive. They're no longer a submarine. That's pretty serious business. So when we get done with a maintenance period, I usually have 3 or 4 submarines that's attending for maintenance service. For they just got off patrol, so they can get back out on patrol before their overhaul. Anyway, we had maintained a subsafe certification, and I had one submarine that they gave us some maintenance activities. They had subsafe maintenance activities that had to be done on a 4,500 PSI or pounds per square inch hydraulic system. It was essential for the maneuvering of the ship and operation of a lot of equipment. Anyway, we had sent the repair guys out of the submarine. It left us, headed out to sea with our repair guys still doing the work, but we got the work done. The tug picked them up, and we were able to issue, my QA department was able to issue a certification letter saying that all the work was done in accordance with the requirements for subsafe and met the requirements specified by subpack, submarine pack for Pacific Fleet. Then we turn it back into a submarine. Otherwise, they cannot dive without that letter. And my QA officer was required to issue that letter. So it was a pretty serious thing, maintaining safety of the personnel and the ship so it can perform its mission. Anyway, in that reactor compartment, just to let you know, in this country, and I'll get to it a little later, the commercial nuclear power and even naval nuclear power has a limited annually 450 metric tons of CO2 through the atmosphere. On top of that, the oil that we use for powering cars and all that, you could take 100 million cars off the road for the amount of fuel that they consume. That is pretty soon. And also nuclear power in this country provides over 50% of the electric power that we see in this country. So it's a pretty big source of power and very small carbon footprint to a lot of things. You know, solar, okay, I've just been coached and I'm rambling, got it. Let's see. This is a missile, these are missile tubes that were on the submarine, 16 of them. As you notice, some of them look like they're straight tubes down, that's true. But some of them are covered with, looks like a cover of some sort. Well, that cover, which I mentioned earlier, the missile never comes in contact with seawater. Those are explosive diaphragms that when we get ready to launch light off those rocket motors to launch the missile, those diaphragms are blown out and the missile comes up through the gas cloud. And so that prevents the seawater from coming into the missile tube and keeps the missile dry. And when those tubes are open and they're loading missile, it's pretty secure. One time I came up out of that AMR-2 hatch and I heard click, click. And I looked around and I had a pistol pointed at me and so I went right back down. It was not healthy. Anyway, this is what it looks like in the missile tube in perspective to a man standing next to it. When you look down one side, that control panel, which is right here, that's part of the monitoring the atmosphere within the missile tubes and taking care of the missiles. Down this side of the ship are various labs, doctor's office. We had a doctor on board and things, and then they got storerooms and things like that. On this deck, they gave us a treadmill. So anyway, that's the missile tube. Then now we come back here to the start getting into the engineering spaces and reactor. This space right here is what's called auxiliary machinery space 1, and it contained very special electrical generators for powering various of the instruments up here in front of the ship, in front of the submarine, and for the missiles. It also had our oxygen generator, which we used electrolysis It's simple chemistry to dissociate the hydrogen from the water, and the hydrogen is pumped overboard. We don't keep hydrogen on board. It's nasty stuff to deal with. It's very flammable and explosive. But the O2, or oxygen, provided all our oxygen needs for it. It's a pretty sophisticated machine that does that. Those oxygen generators, I say use electrolysis, but they're pure nickel cylinders where the water is introduced, pure water is introduced, and the water is subject to electric potential that dissociates. I'm not going to go through the chemistry of electrolysis, but anyway, it works great. Okay, so this is a reactor. And aft, I just told you about the electrical panels and the reactor protective gear. And down in this level is a watch station that I qualified on. It has the submarine's emergency diesel. It has an electric motor that we can lower through the bottom of the ship as an emergency, and it'll drive at about 5 knots or 2 to 5 knots, depending. However, that's an extreme use of it. And then, more importantly, it's we call it a feed water control system. And I'll talk a little bit about that in the construction of a nuclear power plant. And then you get into the engine room spaces. This is where the maneuvering room is, and where to get the engine order telegraph from say how fast the ship goes, and also control of the reactor and monitoring the reactor, and also the distribution of electricity from our ship service turbo generators to take care of all of our household load, hotel loads. And back here is the main engine that drives the propeller. Anyway, that's basically. Here is a diagram, a simple diagram of a nuclear propulsion system. This is the reactor. The fuel is in modules, and the fission process is controlled by use of water and the control rods. The water acts as a moderator to slow down the neutrons from the fission process. And then you got the reactor vessel and the piping from that. All that is not bolted together. It's all welded with, yes, I'm not going to go in the techniques for the welding. Anyway, so this is the primary, what we call the primary system. It's the same in commercial nuclear plants, but the commercial nuclear plants are a lot larger. They're up 1,200 megawatts, and this is about 60 megawatts that we had on our ship. So this is a tea kettle compared to the commercial nuclear power. Anyway, the hot water comes out and goes through what we call steam generators. That's like a radiator on your car, where the air blows over the radiator to cool your coolant for your engine. So it's a huge radiator. And the water is hotter than the water in the generator, and therefore it will boil. And then as water generator boils, the steam is produced, and I'll get to that. But the cooler water, the primary coolant, goes back to the reactor with a main coolant pump and shoot the bulkheads and back to the reactor to get reheated. So now here is the what we call a pressurizer. We keep the reactor at a certain pressure. The pressurizer is just like your pressure cooker at home, if you still have one of those. Uses heaters, and we are able to draw a steam bubble in there by draining down the level. Sometimes we fill it up all the way and have the plant solid water for various things. But anyway, the steam bubble helps, and the temperature in there helps maintain the pressure in the reactor. Okay. And then the steam comes out from the steam generator. It goes through an isolation valve right at this bulkhead called a main steam isolation valve. Then it comes to the big pipes down through the AMR2 into the engine room. The steam goes to the main engine. The main engine is a high-speed turning turbine. It's too high a speed to turn the propeller at that kind of speed. So we have a reduction gear, and that reduction gear goes through, we have a big clutch, we can disengage it. And we have an electric propulsion motor, and we have a mechanical seal that seals seawater from outside from coming into the shaft, the propeller shaft. Let me get a drink. To turn the propeller. Now, so that reduction gear is a very finely machined component. It takes a lot of lubrication and to be able to turn it at the speed we need. Anyway, the steam comes through what we call a condenser, main condenser. It condenses the steam back to water, and all that water goes back to the steam generator. So that's basic. The only difference is that for commercial, the main turbine drives a generator. All the rest of this stuff here is not in a commercial nuclear power plant, but all the rest of the stuff is. We have batteries in the commercial nuclear plant, all that stuff. Okay, anyway. So just for if you have a concern about the radiation on board and the environment, the radiation is virtually negligible. I've accumulated over 50 years, 1.4 RIM. RIM is a Rankine equivalent man. That means the amount of ionizing radiation could damage 1 gram of cells. Okay, so it's very minimal. But what this is saying the amount of long-lived gamma radioactivity, because we don't discharge fission products since 71 within 12 miles shore, and also all our foreign ports support activities has been less than 0.02 curies. Well, but to put that in perspective, if you read through this paragraph, as measured the significance, the total quantity of long-lived radioactivity released within 12 miles of shore in any of the last 50 years is less than the quantity of naturally occurring radioactivity in the volume of saline water occupied by a single nuclear power submarine, saline harbor water, or the quantity of naturally occurring radioactivity in the top inch of soil in a half-acre lot. So it's pretty insignificant. You get more out here than we did get radiation than we did on a submarine. Another aspect, if you look at all that, if a person drank the entire amount of radioactivity discharged in any harbor in the last 50 years, that person would not exceed the annual radiation exposure that the NRC, Nuclear Regulatory Commission, rules or law for an individual nuclear worker does not exceed 5 REM per year. So anyway, that's a bit there that we're pretty safe, and it's a pretty robust. And even when we had 2 nuclear submarines lost, Thresher and the Scorpion, they have done measurements on the radioactive leakage, and is insignificant from the submarines we lost. The 2 nuclear submarines lost. This is the maneuvering room where I showed on the slide where we control the reactor, and the throttle for the main engine is right here. This panel here is the reactor control panel, and the operator is monitoring the reactor that it's responding correctly. And this is the electrical distribution panel, and some of the support systems from the electrical distribution. Now, what's really interesting is that we protect the reactor core at all costs. However, in an extreme emergency, the captain has a choice. He can do what we call a battle short. He goes into one of our reactor protective cabinets, and we flip a switch, and that disables all the protective features for the reactor. It's to prevent us getting sunk, to save our lives. However, I don't know of any submarine other than a test situation have ever used that battle short. So, okay. This is looking into the maneuvering room from a passageway from that auxiliary mission. And right behind that, gentlemen, is we had our distilling plant and our air conditioning plant. One of the earth accidents you can have on a submarine is a loss of air conditioning. Equipment overheats very fast. That's a pretty serious event. We use our air conditioning plant was lithium bromide, and it was very effective in keeping us cool. And then right behind this gentleman was our big distilling plant, and ours was 8,000 gallons per day. It would provide distilled water from seawater, and we would send it through an ion exchange to purify it more, and it went into our tanks that fed water into the steam generators and make up water to the reactor and all that stuff. Anyway, that's that. Now, whoops, I lost my full screen. Well, that was into that. Okay. So the next thing I wanted to cover is make sure, okay, I covered everything there. Yeah, I covered everything there. Oh boy, I only got 15 minutes left. Okay, this has some questions.
Yeah. Two subs that were lost. Where were they lost?
Okay.
Are they still there, or were they recovered?
Okay, the Thresher was lost off the coast of Maine about 300 miles into 8,000 feet of water. And that was a seawater rupture of a line that flooded the submarines, and they couldn't recover. One of the things with the Thresher went through a lot of testing, dynamic testing with explosives near it, just like we did with an aircraft carrier recently, to see how it would react and to sustain damage. But we didn't have the certification of the materials that we do today in our submarines, and that was a major failure that we didn't identify at that time. We lost the Thresher. Now, the Scorpion was lost off the Azores, well, just a couple of years later or something, I don't remember. It was discovered it had something, it may have been, there's a lot of theories. It could have been a fire occurred in the battery, or a torpedo went off, okay, somehow. But it caused the submarine to lose its buoyancy and sink, and it just crushed it. So, and we lost all hands. Yes. Yes, they are. And there's been surveys done to determine if there's been any significant leakage from the reactor core, and there has not been, even after all these years. And I don't think there will be, because it's a pretty robust system in our lifetime, in many children's lifetime, that you'll see any leakage, and I don't think you see it. So anyway, any more questions? Yes.
Yeah, I just had a quick one. How many of this class of submarines are there, and how many of them are out on patrol at any particular time?
I can't give you that on patrol. That's classified. Okay, but at my time, it was at the height of the Cold War, and they constructed 41 fleet ballistic missile submarines, and they were missile platforms and intent to go to a particular patrol area and just kind of circle around at about 2 knots or 5 knots, and just be ready to launch. We were always on a war setting. And I have a pin that where my uniform, I had 6 war patrols like that. There were 41 for freedom. They formed up the one leg of the nuclear triad. If you remember, back in those years, we had Strategic Air Command, and we had the missile land-based silos you see in North Dakota and around. And then we had the submarine service. The submarine service is still a major part of the nuclear deterrence. Of a mutual assured destruction. So we just don't want to get in that kind of a fight. However, we're prepared to do it. And that's the way life was. When she said that this was a dangerous business to operate in, it certainly is. Things can happen, and you're in close proximity to machines. You learn to keep your hands off, and you just don't go around pushing buttons. It's hazardous to your health. In 2008, the USS San Francisco, a fast attack submarine, was going full speed, flank speed to Guam. They hit an undersea mountain that was unmapped, and it crushed the submarine. Survived. One person was killed. When I looked at the pictures, it's probably the watch, the standing watch in the torpedo room, because we had nuclear weapons there too. We always, every section ship had watches, various watches. Probably killed him because it basically crushed that forward part of the ship. So it is a dangerous business because you're flying by instruments, just like in an airplane in the cloud. What you see out there, you don't see. We don't have windows. It's all by instruments and sonar. We do a very excellent job, but it's hazardous. And there have been collisions. There was, just a few years ago, a submarine coming out of port collided with a Russian submarine. They were silent. And I don't know how the admiralty courts deal with that, but my submarine I was on, the has two crews, because you come off, I was on board, you're on undersea for 70 days and you come off board for more training. And the gold crew would take over. I was on the blue crew. Well, the gold crew sunk a ship. They got an award for sinking the most enemy tonnage in peacetime. It was down at Rota, Spain, and it was being towed by a tugboat that was coming into port. They had about 1,000 yards of cable out. The tugboat slowed down, but what they were towing, there was a scrapped freighter, and they had other scrap ships in its hulls. It didn't slow down, so the cable dropped into the water, tow cable, so they could reel it, but the submarine caught it on their way out. And the captain, the ship was angling down, and so the captain ordered emergency blow, and the submarine surfaced under the ship, punched a hole in the bottom, slid up against the side. We seen who were on the tanker jumping off. They were going down, but they were all rescued. Nobody was hurt. And so, anyway, any other questions?
So is it a nuclear submarine because it's propelled by nuclear energy?
Yes.
Or is it because of the weapons that are nuclear?
It's because it's propelled by nuclear power. We use a nuclear power to propel it.
But not to be confused with nuclear weapons?
That's right. It's not, nuclear weapons are different. And so. Yes, sir.
How do we stack up with the rest of the world? Are we competent?
I can't answer that. In today's environment, all I know, what I've read, we're very sophisticated it's important that we remain silent in what we do. In Idaho, the Naval Sea Systems Command has a facility at a lake, I forgot the name, but at a lake, with a mock-up of the Seawolf submarine. It's one of our more advanced submarines, doing acoustic testing to make sure we can make the submarines quieter.
How fast will our subs go?
We could go more than 20 knots. That's all I can say. And the submarine that hit the mountain can do more than 30. Oh, I should point out, our nuclear ships are built as race cars. We've got to change power and speed fast. And so we operate at very low power most of the time. Commercial nuclear power plants are designed to operate at 100% power. And because we're generating electricity, that's when they're most efficient and less vulnerable to transients. So,
how do foreign countries regard our?
Pardon?
How do foreign countries Saying new.
I don't know. I cannot give you an assessment. I was never in that part of the intelligence field as far as comparing.
If I were a foreign agent, I'd really want to know, wouldn't I?
Pardon?
If I were a foreign agent, I'd really want to know, wouldn't I?
Yes. If I didn't have a need to know, I don't want to know. It's scary. I tell you what, if anybody says that they don't have a fear when they dive, they're foolish. We had a gentleman on board on my submarine. We were doing maintenance, and he took out a piece of a zinc plug out of a heat exchanger, and it was about a 2-inch hole that sprayed seawater on the back of our reactive pec gear. At the same time that occurred, I was down the lower level leading a crew doing preventive maintenance on the emergency diesel. And I get a call from maneuvering, and that was back in the engineering space, that said, how long would it take to put the diesel back together if we need it? And I told him it would take about 20 minutes. And at that time, it's just when he was saying that, we get the alarm of flooding. I had water pouring down all over me. And we immediately isolated the system that was associated with the flooding and stopped it, okay? But we sat dead in the water for 16 hours on the surface on reduced electrical power on the battery or diesel. And we're supposed to be a silent missile platform. Nobody knows where we're at. Here we are. That was an exciting time. It was a very hard time for all of us to get that equipment back up running again. We used a lot of spare parts.
The United States usually made a deal with Australia to buy nuclear.
Yeah, I saw that in the news.
Were they a lot better than the French ones? Because they had a deal with France.
I can't discuss that. Thank you for asking. If you have questions on the capability, when I went through on our submarine, the modern day submarines, and it's, I look at where I was on, it was in the 60s. They have advanced so much, and I did a lot of maintenance on them, and we're about out of time. I've got 4 more minutes. They're much more advanced, and I was involved in the research and development of those submarines back in the 80s. I retired from the Navy in 1985 after 20 years, 3 months of service. It was a great career, unusual career, but it was interesting.
And then you went on to a career
in the commercial nuclear power field,
overseeing
our commercial nuclear electric generating plants. I worked for a company called IMPO, which was independent of the commercial nuclear, but in the nuclear industry, commercial nuclear industry, but independent. And we graded their performance. And if they didn't do well, we had the power to shut them down. So I spent 14 years doing that. It was a challenging time when you're talking to a CEO or something like that, he's not doing well. And this person needs to be replaced, or you got to replace this team, and you're not doing well maintaining a plant. You got to spend the time and money. End of discussion.
How do you get radio signals there?
How do you get radio signals when you're out to sea?
We had a floating wire, and we had antennas in the sail of the submarine. The big thing that sticks up from the big round tube has periscopes in it, has radio antennas, radar. It's we were able also to hear with the sonar, even in the rear of our ship, so somebody can't sneak up on us.
I'm really impressed with the
skills that are required, the various skills that are required for the crew. I have one question. How are these people selected to be? Do they say, hey, I want to be on a submarine? And one more thing. I got very claustrophobic when you were doing this. Is there some way that they're able to
they're tested.
stop this so that people can cope with that?
Yes, we were tested on our ability to operate in confined spaces. And part of my 6 months training, 6 months of training in Idaho, I was attached to a submarine prototype and how to operate and function in that. You got to be able to have a decent interpersonal skills to get along with people, because that person next to you is covering your back. And so how are the people selected? Well, first of all, it's intelligence. It's known in the Navy that the nuclear power school and trainees, the most arduous training that the Navy has to offer officers and enlisted. It's hard. Even those who have college degrees or doctorates sometimes fail and are not able to handle it. It's pretty fast paced. And I do remember a lot of it because one of my certifications in the commercial nuclear field, I was certified as a senior reactor operator for boiling water reactors. It's a little different design in pressure water, but fundamentally the same thing. And I worked for INPO, the Institute of Nuclear Power Operations. They sent me to 3 months of training to get my SRO certification, senior reactor operator certification. I had to go back through all my theoretical training I received in the Navy, plus new stuff, and then demonstrate my knowledge and skills on a simulator. And those simulators are very, very accurate on simulating an operation at the operational plant over which we were training on. I was training on the Limerick nuclear generating station. And so we had to demonstrate our ability to command and control from various accident scenarios. And so, plus start up and shut down safely. Other than that, it was pretty arduous. So, but it's intelligence. And then I had about 2 years of various schooling, 6 months of nuclear power school, which included anything you could think of: nuclear physics, metallurgy, reactor kinetics, math, all the way from basic algebra through integral calculus, electrical theory, and the components we'll be faced with working on a submarine. It was 6 months of intensive. Then I also went to Idaho. I thought it was Iowa. I was going to be near my family. My geography was screwed up. I went to Idaho for 6 more months of training on a nuclear prototype. And that was S1W. That was the prototype plant for the Nautilus. And anyway, we're well over this time, but I don't know if that gives you a feeling for it. Was not, hey, here's the submarine, go work. It took, before I even stepped on it, like I said, it was pretty arduous training. So I did very well, but nonetheless, thank you.